So we are going to today finish up talking about graphing through some applications. And we did look at an application yesterday, but we're going to look today at some applications where we are not given the two equations in the system in the problem. We actually have to come up with them through information that we're given ourselves. And this is going to be a type of question that we're going to look at throughout this entire unit. We're going to do a few of them every single day. And we're just going to basically use whatever method we're using to solve on that day to solve these types of problems as well. Okay? So here we go. Write a linear system to model this situation. To visit the Head Smashed In Buffalo Jump Interpretive Center near Fort Macleod, Alberta, the admission fee is $5 for a student and $9 for an adult. In 1 hour, 32 people entered the center and a total of $180 in admission fees was collected. Okay? So we need to write a linear system to model this situation. A linear system means two unknowns, two equations. So let's talk about how to do this, okay? Now, some people, by the way, are really good at this, and it's just really intuitive, and they can do it immediately. And if that's you, then that's great. Just be thankful. That's a nice sort of skill, talent to have. What I'd like to do, though, is try and break it down as much as possible, because it can seem overwhelming if you're not sure where to start. Okay? So the first thing that I always recommend is, and I'm going to do it up here just because I know I'm going to run low on space, is to define your variables. What are the unknowns in this problem? And often, not always, but often, if you look at the very last part of the question, what's being asked for, it can help you to determine what those are. So in the second part, where it says graph the linear system, then solve this problem, how many students and how many adults visited the center at this time? Okay. What are the two unknowns? Yeah. Yeah, number of students and number of adults. Those are our two unknowns. So I like to do that in a let statement. Okay, so I might do something like this. Let the number of adults be A, and let the number of students be S. Okay, now I have something to work with. All right? Now, the second step is we are going to try to work towards writing out two equations that relate these two variables to one another. Maybe I'll do that here. Okay, now this sometimes seems overwhelming, so I'm going to tell you a couple things that you can look out for. One thing to look out for are totals. If you see a total number of this or a total number of that in the problem, almost always that will lead to one equation. Okay, so you can look for totals. Okay, sometimes you don't have a total, but you might have something like this. The number of students is 5 more than the number of adults. That's not a total, but it is a relationship between the two variables, right? That's not what we see here, but that could come up. So, or a relationship or connection. So that might be 1 is 2 more than the other, or 1 is 2 less than the other. It might be 1 is a third of the other, or 5 times the other, something like that. Okay? But that is some sort of connection between the two variables. Okay? Now, what do you see here in this problem that we can use to build some equations? Yeah?
A plus S equals 32.
Yeah, so that refers to 32 people entered. That's the total number of people that entered is 32. And you got it right away. But sometimes if you're having trouble, you can come up with like a half English, half math equation. So you might have something like total number of people is 32. Right? And then if I have A adults and S students, the total number of people is going to be A plus S. Okay, so there's one equation. I need another one though. Yeah?
Make a relationship of the total admission fee. So
yeah.
5S plus 9A.
Total admission fee, yes. So we also know how much these people spent to get into this interpretive center. So that's our second one. Total admission, oh, I think that's just one D, is $180, okay? Now, yeah, if the adults are $9 each and there's A adults, the admission fees just from the adults is going to be 9A. And if the students are $5 each, and there's S students rather, the students are going to be 5S. I probably should have used something other than S because S's look like 5s, but anyway, equals 180. Okay, these two equations make up the system. That's the second step. And that's often the most difficult. Okay, now the third step in general, because remember today so far we've just learned how to do this graphically, but ultimately you will have 3 methods to solve, is to solve it using any method. Okay, so in step 3, we're going to solve the system. Okay, and you can do that graphically or algebraically. We'll look at one of the algebraic methods towards the end of class today, but that was something called either substitution or elimination. Okay, today we're going to practice graphing. So we have these two equations, A plus S equals 32, and A plus 5S equals, no, 9A, sorry, plus 5S equals 180. I'm trying to really make my S's and my 5s different. Don't know how it's working out, but anyway. Okay, we're going to do this graphically. So to graph these, how would you start? Yeah.
You need to put them into slopes.
Yeah, so we either have to put them in slope-intercept form, or we could try using intercepts. When you're solving applications graphically, most of the time I would recommend doing it using technology. And the reason for that is that often the numbers are quite large. And so to be able to graph it by hand and get a very accurate intersection point is not easy. Okay, so I would personally probably recommend doing this using technology, but of course you could also try doing it by hand. You would at least get a rough idea as well. If you're graphing using technology, you have to put these into slope-intercept form. If you're graphing by hand, you could either do that, or you could find the intercepts, the x and the y intercept for each equation and just connect those 2 points. Okay, now when we put into slope-intercept form, we usually isolate y, which is the dependent variable. In this case, is there a clear dependent and independent variable? No. So when that happens, just pick one. Decide A is going to be independent or S is going to be independent. You just have to make sure that you isolate the same variable in each equation. Okay? So I don't know, maybe I will isolate A. Okay, so if I isolate A, I just basically have to subtract S from both sides. So that'll give me A equals negative S plus 32. So there's one. Okay. With the second one, if I isolate A, I have to do a little bit more work because I have that coefficient of 9 that I have to deal with as well. But again, I could, start by subtracting 5s. And we end up with 9a equals negative 5s plus 180. Okay? And then we can divide everything by 9. Okay, and then if you can simplify. So, I'm not going to do anything with this negative 5 over 9, but I can simplify 180 over 9. That's 20. So that becomes, I'll write this over here, A equals negative 5 over 9s plus 20. And I'm going to put these into my calculator. Okay, so actually I did this last period. So I'm just going to actually clear my memory so that you guys can see from the start how this would go. Okay, so here's the Casio and the TI. In the TI, I can just go clear. Okay. So I'm ready to graph on the TI. On the Casio, I'm going to go to Menu and select Graph, which is in the top left corner right now. Okay, and then I'm going to enter in my two equations. So the first one was negative s plus 32. Of course, we have to use the variables x and y, so negative x plus 32. And then the second one was negative 5 over 9x plus 20. Now on the Casio, when you're entering in a coefficient that is a fraction, you have to put that into brackets because otherwise it'll automatically put the variable in the denominator, which we don't want. So I'm going to just stick this in brackets, negative 5 divided by 9, x plus 20. Okay, and you can see it actually turns it into a fraction. Okay, now I could draw, I'm going to draw this, but I don't actually see anything. Why is that? Yeah. Window settings, yeah. So I'm going to go to Window, and when you are doing this, you have to really sort of put yourself into the problem and say, okay, X represents S, number of students. What's the minimum number of students who could be at this interpretive center, and what's the maximum number of students that could be at this interpretive center? What's the minimum? 0, yes. And what's the maximum? 32, because we're told 32 people attend. Okay, and my scale of 1 is just fine. Oh, whoops, I want to go back. Now my X will be fine. There we go. Too fast. Okay, and then for the Y, it's going to be the exact same thing because it's the same sort of constraints. There's 32 people in total, so the minimum number of adults is 0, and the maximum is also 32. And now when I draw it, something went wrong here. Hold on a second.
Is there a negative x?
No, hold on. Oh, look at that. My y min is at 32. That should be at 0. And my y max, I'm actually surprised that it even did that, is 32, that it even graphed that. Okay, there we go. That's better. There we go. Okay, so there's the intersection point. On the TI, we're going to enter in negative x plus 32 and negative 5 over 9 x plus 20. Okay, and then of course we have to change the window settings to be exactly the same. And then we can hit graph, and you'll see the exact same image. Okay, now to find intersection points, how do we do that on the Casio? Yep. Yeah, F5 for everything's under G solve, right? And then F5 again, because we're trying to find an intersection point. And we are told that that intersection point is at x equals 27, y equals 5. Okay, and then on the TI, what do we need to do? To find the intersection point on a TI. Yep.
Calculate.
Yeah, so we have to hit the second first, and then that, because the calculate is up here in blue. And then we're going to select number 5 for intersect. Okay, and then you can drag the cursor down closer to the intersection point on one of the lines and hit enter. And then it'll jump down to the second one, hit enter again. And do we want to guess? Yes, we do. Hit enter again, and then you get that same point. Okay, now do you guys remember how we actually write this out so that we show our work? What do we have to do? How do we show our work with this for solving graphically? Yeah. Yeah, so you draw like a rectangle for the window of your calculator. And then above you have to write the two equations. So that's y1 equals negative x plus 32. y2 equals negative 5 over 9x plus 20. Yep.
Below it, the rectangle.
Right.
Right. X min, X max, X scale, and then
Yeah. Window settings. So that was for both of them, 0, 32, and 1. Okay, and then we just do a rough sketch. So that looked something like this. And this point over here was 27, 5. Okay, now we still have to answer the question. The question was, how many students and how many adults visited the center at this time? So what's the answer to that? What does the x variable represent? Yep. Careful. So here we have a equals negative s plus 32. y1 equals negative x plus 32. Yes, so x is s. X is the number of students. And y is the number of adults. Okay, so far so good? Okay, let's look at another one. So we're gonna start this one together, and then I'm gonna get you guys to try and solve it graphically. In Calgary, a school raised $195 by collecting 3,000 items for recycling. The school received 5 cents for each pop can and 20 cents for each large plastic bottle. How many of each type of item were there? Okay, well, step 1, define variables. What are we trying to find here? What do we want to know? Yeah, Anna.
the pop can and the plastic bottle.
Yes. What specifically about the pop can and the plastic bottle? Yeah,
How many of each there were?
exactly. The number of each, right? So let number of pop cans be P, and let the number of bottles be B. And you guys can see, like, you can be super lazy around, like, write it out, but you don't have to use punctuation. You could cut out words. You could do it in point form. I don't really care about that, right? So as long as the information is down there, that's fine. If you don't capitalize it, it's okay with me. Although I do appreciate people who like grammar. Okay, so there we go. Now, in step 2, we've got to come up with some equations. All right, so what information can we take out of what we're given to build some equations? What's going to be important? Yeah.
Since there's 3,000 items
Yeah. All together, there's 3,000 items. So total items is 3,000. Yeah, and that represents P plus B. Okay. Is there another piece of information that we can work with? Yeah.
With the pricing, you do 0.05 cents equals P plus 0.2 B, and then it equals 190.
Exactly. Yeah. So the total money collected, right? Is 195. And if you even can't get to this part yet or can't get to the equation that Anna just mentioned, then write this down and start to work with that. That is a total. Okay? Now, each pop can gets you 5 cents. So what would be an expression for the amount of money you get from the pop cans? Yeah.
0.05p.
Right, 0.05p. Because remember, one trap that sometimes people fall into is that the pricing for the items is given in cents and the money is given in dollars. So you have to just make sure that your units are consistent, right? So you either have to write everything in cents or write everything in dollars. Either or is fine. Okay, and then what's the amount of money from the bottles? Yeah. 0.2B, right, equals 195. So this would be in dollars. If you wanted to do it in cents, you could do that too, right? So the equation would be 5P plus 20B, but then we'd have to convert $195 into cents. How much is $195 in cents? Yeah.
19,500.
Right, so just multiply by 100. You could do that too, either or. Okay, so we've got a system. So you have to use this equation and one of these two to solve this graphically. So I would like you guys to work on that now, please. To solve systems is called substitution. And it's called substitution because at some point in the process, we're going to be substituting for a variable. Yep.
This is just clarifying something, but is this the method where you isolate y and 1?
Yeah, so we'll get there.
Substitute in the
Yep.
second equation here.
Okay, so we're going to go through the steps of substitution using an example, okay? Because I think it's really hard to describe them without actually seeing what's happening, okay? So we'll use this example, solving this system 3x plus 4y equals -4, x plus 2y equals 2, to look at how to do this using substitution, okay? So I'm going to start writing the steps up here because I know from my last period that I'm going to run out of room if I just do it over here. The first step, there we go, is to isolate either variable from either equation. Or you should isolate one variable from either equation. Okay, so if we look at this system here, we have a choice of 4 different things. X in the first, Y in the first, X in the second, or Y in the second. It doesn't matter which one you pick. However, sometimes picking certain ones over others can make your life a little easier in terms of solving the system. Okay, so when I look at this particular system, there is one that I would pick for sure as my first go-to. There are 2 that would be totally fine to pick, and there's one that I would not pick. So I want you guys to think about which one would I pick, and even more interesting. Which one wouldn't I pick to isolate? Okay, let's start with which one would I pick. This guy, x first, y first, x second, y second. Which of those is going to be the easiest? What's easiest to isolate? That, or that? Yes. The second x, yes, because I can do that in one step, right? I just have to subtract 2y, and I've got the second x isolated. So pick the easiest. Okay, now, which one do you think I wouldn't pick? Yeah.
3x.
Yeah, the first x. Why? Why wouldn't I pick that one? Yeah, Kiara. Yeah, because then I'm going to have to divide everything by 3 at some point. When I divide everything by 3, I have a non-terminating decimal. And then I cannot switch to decimals. I have to do everything using fractions, which means I'm going to have to possibly add and subtract fractions, multiply and divide fractions, which is fine, and you could totally do that way, and if you like working with fractions, go ahead. But if I pick one of the ones where the coefficient is, when you divide it, you get a terminating decimal, then you could also do everything in decimals because you never have to round. So dividing by 2, 4, 8, 5, 10, something like that, those are all nice numbers to work with. Okay, so I'm going to start by isolating the x in the first. So I'll subtract 2y, and I get that x equals 2 minus 2y. Okay, so that's the first step. In the second step, you are going to sub for the variable you isolated into the other equation. Substitute the variable you isolated into the other equation. Okay, so if I subbed in the first, if I isolated in the first, I sub into the second. If I isolated in the second, I sub into the first. I isolated into the second, so I'm going to sub into the first. So what I do is I write that equation out. I'm subbing into the first one because I isolated in the second. So 3x plus 4y equals -4. And what I'm going to sub is the variable that I isolated, which is x. And what I'm going to sub in for x is this, 2y minus 2. Okay, so what I like to do is just replace it with a set of brackets initially, and then pop this into the brackets, 2 minus 2y. Okay, so that's my second step. That's why it's called substitution. What do you think I'm going to do next? Yes? Simplify and then eventually solve. Yes. So we need to solve this equation. And the reason that we do this, by the way, is that if we can reduce one of the equations down to one variable, that's solvable. Okay? And once we can solve for the one variable, we can go back and figure out the first variable. Okay? So that's step 3. Solve. So we have 3 times 2 minus 2y plus 4y equals -4. And then, yes, you're absolutely right. We do have to simplify because before we can start isolating a variable, both sides of the equation must be simplified. So I'm going to distribute. That's going to give me 6 minus 6y plus 4y equals -4. And then I can keep going because I can collect these y terms, right? So I'll have 6, and then negative 6 plus 4 is minus 2y equals negative 4. Okay, and then I can subtract 6 from both sides so that I just have the y term isolated. And that gives me negative 2y equals negative 10. Yeah?
Do you, do you have to divide by negative?
Yeah, then we just divide by negative 2. And we now have our y value. Y equals 5. Okay? All right, now what? What do you think we have to do next? Yes?
Do you need a check? So do we need to plug in 5 and substitute in 4?
Okay. Yeah, so we do need to sub in the 5 for y, but that's not actually checking. The solution to a system is the value of both variables that solve the system. So what we need to do in step 4 is use the y equals 5 to get x. Okay? And you can actually use either equation to do this. Sub that y equals 5 into either equation. It doesn't matter. You should end up with the same result. What I personally like to do is use the equation that I isolated in step 1, because then I don't have to solve anything. X is already isolated. So I'm going to write that out. It was x equals 2 minus 2y, and I'm going to sub in a 5 for y, or sorry, for y. X equals 2 minus 2 times 5. Okay, and that is 2 minus 10. So x equals negative 8. Here we go. This is the solution to the system. Okay, you have to write the value of both variables. Now, there is one other step that you can do that I recommend that you do that's optional. What do you think that is? Yeah. Check, verify, right? If it's the solution to the system, that means that when you plug in a negative 8 for x and a 5 for y, in both equations you should have equality. Okay, so I'm gonna maybe, let's see, do I have room? I don't think I'm gonna have room. I think I'm gonna have to do it down below because I'm gonna run out of room. So I'll just extend this a little bit. But the last step, which is optional, is to verify. Right, so one of the equations was x plus 2y equals 2. And the other one, it was 3x plus 4y equals negative 4, right? I think. And we're going to plug in the point x equals negative 8, y equals 5. Okay, so I want to check both. If x is negative 8 plus 2 times 5, that's the left side. Right side is 2. And when I do this, I get negative 8 plus 10, which is 2. So this checks out. Left side equals the right side. And then I have to do it in the other equation as well. Okay, so 3x, 3 times negative 8, plus 4y, 4 times 5, is the left side. The right side is negative 4. And the left side here is 3 times negative 8, negative 24, and then plus 20. And that also comes to negative 4, which is good. Okay, and by the way, if you make a mistake somewhere and you verify, and then you're like, hey, you write on your assessment, I know I made a mistake because my solution doesn't satisfy both equations, that shows me a very, very, very high level of understanding, right? Even if you can't find your mistake. I can't find my mistakes a lot of the time. So that even just being able to do that, I'm looking for understanding, right? Do you understand that when you solve a system, the value of each variable when plugged in satisfies both equations? And that shows a very good understanding of that. Okay, so yeah, do this because you may end up losing less marks if you make a mistake, kind of thing, right? Okay, let's try a couple more of these and then we will call it a day. All right, now this system right here, 3m plus n equals 2, 2m plus 5n equals 23. Which variable would you isolate there? Yeah. N in which equation?
The first one.
The first one, yeah. I would too. There's only one that I wouldn't choose. Which one wouldn't I choose, do you think? Yeah. Yeah. Yeah, this guy, the m in the first one, because then we have to divide by 3. That's not always fun. Okay, so I'm going to choose, and these ones would be okay, right? It would take more than one step to isolate, but that's fine. We would still end up with terminating decimals, and so we could just work with decimals. Okay, so let's start in step 1. Okay, if I want to isolate n, I have to subtract 3m from both sides. So I will have n equals 2 minus 3m. Okay, this actually can go quite quickly if you're not writing out every single step. Yeah?
Does it matter if you put negative 3m first? Or?
No. Yeah, no, you could write negative 3m plus 2. That would be fine too. Okay. All right, so in our second step, we're going to substitute. And we're going to substitute into the other equation, which is the second one, 2m plus 5n. Which variable am I going to sub? Yeah, n, yeah. So I'm actually just going to go 2m plus 5 bracket equals 23. And then I can do that all in one go. Right? And in the brackets, I'm going to put this. 2 minus 3m. Okay, so that's the second step. In the third step, I've got to solve this. And what you'll find is that this third step in terms of solving, it might be a multi-step equation, but every time you're working with systems, that process is exactly the same every single time. You always have to distribute. You always have to collect like terms. You always have to bring the number over. It's very repetitive, okay? So if you practice it a bit, you'll get it. All right, so we're going to have 2m plus 10 minus 15m equals 23. And then, of course, we can combine the m terms. So 2 minus 15 is negative 13. Negative 13m plus 10 equals 23. And then isolate the m term by subtracting 10. And we got negative 13m equals 13. So, yeah.
Then you divide by negative 13 and it's n equals negative 1.
Yeah. And honestly, like if you just know if negative 13m equals 13, that m equals negative 1, you could just write that out, right? You don't have to show me every single little step. Okay, so we got m. Now we got to find n. So this is step 4. And we know that n equals 2 minus 3m. And we know that m equals negative 1. So we can plug a negative 1 in here. And that is 2. And then negative 3 times negative 1 is plus 3. So n equals 5. All right. How are we doing? Good? All right, let's try one more and then we're going to call it a day. All right, so in this last system for today, which variable would you isolate? Or which variable wouldn't you isolate? Yeah. You would isolate the second x? Yeah, okay, that's a good option. Is there any other good option? Yeah. The first x, yeah. So if you divide by 5 or you divide by 4, you will always get a terminating decimal, right? So those are both good options in my opinion. The ones that I wouldn't do are these ones, because as soon as you have a factor of 6 in there, or sorry, a factor of 3 in there, then you will get a repeating decimal, which means you have to do everything in fractions. Yeah, so either of those are fine. I don't know, which one do you guys want to do? Okay, we'll do the first one, this guy. So in step 1, 5x plus 3y, no, minus 3y equals 18. So for isolating x, we first have to move the 3y over. So we'll add 3y to both sides, right? And we have 5x equals 3y plus 18. And then we can divide everything by 5. Okay, now here what I would do is actually figure out the decimal for that. What is 3 over 5 as a decimal? Yeah, 0.6y plus 18 over 5 is 3.6. Okay, and then I don't have to deal with any fractions anymore. Okay, so in my second step, I have to now sub into the other equation. So I'm going to sub into the 4x minus 6y equals 18. Which variable am I going to replace? Yeah, x, yeah, because I isolated the x. So 4 set of brackets minus 6y equals 18. And in that set of brackets, I'm going to put this. 0.6y plus 3.6. Okay, and then I have to, do the algebra in step 3. I got to solve. So distribute 4 times 6 is 24. So this is going to be 2.4y, and then 4 times 3.6 is what? 10.8, is that right? 4 times 36. No, it's more. What is it? 14.4, thank you. Plus 144, yeah, 14, oh, wait, 14.4. Minus 6y equals 18. Okay, and then of course we've got to combine the y terms. So 2.4 minus 6 is negative 3.6y plus 14.4 equals 18. And of course, like if you need to do that on a calculator, please do. Okay, and these calculations as well, right? You can do 4 times 3.6 on a calculator, no problems there. And then the next step, what would we do next here? Yeah?
I have a question. How did you get negative 3.6y?
I went 2.4 minus 6. Because we're collecting the y terms, right? So we would like add or subtract their coefficients. Okay, yeah, so what do we do next? Yeah?
Divide everything by 3.6.
You could at this point. I would do something else first though. Yeah, subtract the 14.4. And we will get, this goes away, right? So negative 3.6y equals 18 minus 14.4 is 3.6. Okay, so what's y? Y equals negative 1, yeah. Okay, so that's step 3. And then in step 4, we got to get the other variable. So I'm going to look at the isolation step in step 1 and use that. And then I'll just sub in the negative 1 for y. We actually do substitution twice here, right? Once we sub in an expression, and then once we sub in that value. And I believe, what does that come out to be? 3? I think so. Because 0.6 times negative 1 is negative 0.6 plus 3.6 is just 3. And there is our other variable. And together, these make the solution. X equals 3, y equals negative 1. Okay. All right, so I'm going to end there for today, and we're going to continue working on this on Monday. Yes?
If you're multiplying 0.6 by -1, wouldn't it be -0.6?
Yeah, so negative 0.6 plus 3.6 is 3.
Oh.
Yeah, yeah.